Hello and welcome to Introduction to Big Data and Hadoop. My name is Ravi Nalan and I have an overall experience of 20 years and big data experience of 4 years in both training and development. Obviously, you are looking at this video because you need to handle a lot of data on something that is not working currently with your existing systems, and you want to explore something different, which I'm going to introduce you in today's big data session and a few Hadoop concepts. So let me first introduce to you what is big data. Answer is a simple question: what is big data? So big data is usually defined in three different terms. The first one is the volume, the second one is the velocity, and the third one is variety. And there are many other dimensions to it also, like veracity, value, and validation. But let's concentrate only on the first three most important dimensions of big data, which are volume, velocity, and variety. So today we are actually storing a large amounts of data in our existing systems because of the digitalization of all the data, wherein which we are getting a lot of data from internet and also many other sources. So now we are actually storing the data in terms of terabytes, hundreds and thousands of terabytes. We are even going into petabytes of data, exabytes of data, and now we are at a juncture where we are going to zettabytes of data also. If we don't take care of this particular data, then it's going to be very difficult in the future to handle and process this data. So whenever a lot of data is coming into our system, we call that as volume of data. And today, many of the companies are actually storing huge amounts of data in terms of hundreds and thousands of terabytes, right? Like in many of the phone connections also everybody is using in this whole world. If you add them up together, there are like 6 billion people who are actually using almost everyone is using a cell phone, so we need to store a lot of data in our systems, right? That data can be enter into our system maybe within the next 1 year, or it may enter into our system in the next 6 months, or even in 1 month, and it can come even in the next 1 hour also, right? So the rate at which the data is coming into our system is what we call it as a velocity of the data. So big data is not just about the volume of the data, it's also about the velocity of the data, meaning the rate at which the data is entering into our system. So if you look at a New York Stock Exchange, where 1 terabyte of trade information is being traded every session, which is a huge amount of data. And if you don't handle and process this data immediately, then you will not be able to do any kind of analysis on top of that particular data. And also, because of volume and velocity of the data, the current database systems are not able to hold a lot of data in them. So people are now storing the same data in different formats, other than how database stores the data, right? Maybe in a JSON file, it's a JavaScript object notation file, or even a CSV file, or a comma separated file, or even an XML file, right? So there are many other formats in which people are now currently storing the data, and each one needs its own way of processing it so that you can analyze that particular data. So we call this as a semi-structured data or unstructured data. So a typical database will have a structured data, meaning it has a proper schema for that particular data so that you can run SQL queries. But for unstructured data, you cannot have an SQL. You need to have your own processing engine for each and every type of data. So if you look at Facebook, or if you look at Twitter, or if you look at YouTube, they store huge amount of content in their servers. They store it in a lot of unstructured forms of the data so that they can process billions and billions pieces of content, right? So now if we want to clearly define what exactly is big data. So big data is a term applied to data sets whose size is beyond the ability of commonly used software tools to capture, manage, and process the data within a tolerable elapsed time. So as it's very clear from the definition here, because of the volume, velocity, and variety of the data, that is coming into our system, the current existing tools which we are currently using, like databases and many other SAP tools, we're not able to process the same data because of the volume and the rate at which the data are coming into our system, which is the velocity of the data. We're not able to capture, manage, and process the data within the elapsed time, tolerable elapsed time, which means that we're able to process the query, but it might take much more longer time, right? Which is not acceptable in the current industry standards. And Gartner predicts that 800% of data growth in the next 5 years. Data is always going to grow, and 80 to 90% of the data produced today is also unstructured, which is going to cause more and more problems. So we are in with a lot of challenges on of big data. So first of the challenges is that how can we capture and deliver the data to right people in real time, right? Different people look at the same kind of data in different ways. So how we are going to satisfy those needs? And the data is in different forms. So how can we understand and analyze the data in a variety of those forms? When we store data, it needs a computer and a computational capacity. So whenever we store data, and if you want to analyze that particular data, it needs to have a RAM, it needs to have a CPU. So how are we going to analyze the data given the size and computation capacity of our systems, right? So when you look at a computation capacity, we look at the hard disk, we look at the RAM, we look at how many cores in the system, which measures the CPU. These days, the storage capacities of our systems are increasing. Now we can store 1 terabyte of data or even 2 terabytes of data in our laptops. But that doesn't mean that you can process all of that particular data at the same time, because we have the RAM which is not keeping up with the storage of our system. Meaning, I have typically my system supports an 8 GB or a 16 GB, which can be extended up to 64 GB of ROM, but not beyond that. So if you have 2 terabytes of data on your system, definitely it cannot just process all that data, because it has a limited amount of RAM and limited amount of processing power. Suppose if I have 100 terabytes of data, then if I give you one system at 150, if you scan the data at 50 Mbps, then it takes like 23 days to process the particular data, which is going to be very huge in terms of the industry standards. So in order to improve the performance, we can add more and more hardware to it, meaning we can vertically scale our system to match the performance. But still, it might come down to maybe 20 or 19 days, which is definitely not acceptable as per the industry standards. So whenever we want more performance, and when the data is continuously increasing in terms of volume and velocity, vertical scaling is not going to help us. So we need to go for a distributed solution, or we also call it as horizontal scaling, meaning I'm going to use, instead of one computer, I'm going to use hundreds of computers. Maybe, for example, if I take 1,000 node cluster is nothing but a collection of different machines, or we call this nodes. So now if I start processing this particular data on all the machines, by breaking this 100 terabytes of data into smaller data sets, I could actually achieve a performance of 33 minutes. But we have our own problems with our distributed solutions. How we are going to break the data, and how we are going to distribute the data onto multiple machines, and how we are going to process the data on multiple machines, and if each machine is going to give a certain amount of output, how I'm going to read the data from the hard disk, and then aggregate the data and give it as a single solution. And in the meantime, we may get actually a lot of hardware problems, because we are not dealing with a single machine, we are dealing with multiple machines. And our traditional systems are not meant for scaling, and they are not reliable, and they even become expensive when you invest more on the hardware, right? So there are so many technologies which are going to support big data. A lot of technologies have come into the market to support big data. And onto the right side of the screen, we can see there is HP Vertica, Aster Data, Green Clump, like so many companies which have come, which has invested huge amount of dollars in order to use the distributed technologies to solve this big data problem. But the problem they actually faced was in terms of software, which was very costly and also proprietary, and in terms of hardware. In order not that hardware systems to fail, they invest a lot on expensive hardware, which actually shooted their investments a lot. And if you're not going to get a return on investment, the you can basically soon close your business. So at the same time, when the industry is facing all these problems, the Hadoop technology has come into the market and try to address these two issues which the current market is facing. The first one is in terms of the software. So Hadoop software is open source software, meaning that it is available free of cost from Apache, uh, and its hardware is also cheaper and it can run on commodity hardware. So commodity hardware is a cheaper hardware where you don't really need to use any expensive machines. This is possible because of the fault tolerance feature of Hadoop, where if process breaks on one machine, then it can actually go to another machine and then continue to process the data. And open source software is, even though it is free of cost, it is very difficult to get support for the bugs that you are going to get out of it. So companies like Cloudera, Hortonworks, IBM, and Mapper have come together, and then they started distributing the Apache Hadoop software with their own package and distribution. And they are currently serving the thousands of clients to solve any problem in production in terms of providing a lot of support. So now, what is Hadoop? Apache Hadoop is a software framework that supports data-intensive distributed application under a free license. And it enables applications to work with thousands of nodes and petabytes of data. Now that we have so much of data, and definitely we need more than one machine, in fact, thousands of machines. So Hadoop is the one which is going to help us process this, distribute the data, and process this data across many and many nodes. So Hadoop was actually inspired from Google's MapReduce and Google file system. So whenever you want to attack a distributed problem, the first question that comes to our mind is how do I distribute the data? And Google proposed a solution in terms of a white paper called GFS paper, where they analyzed a lot of this data and then came up with a way you can actually store data in a distributed way in a much more efficient way. And once you distribute the data, you need to process the data. So they came up with something called Google's MapReduce, where you can actually process the data in a very efficient way. And why do people need to go for Hadoop? Right? There are more than one reason why people need to go for Hadoop. It is accessible because Hadoop runs on large clusters of commodity machines, or if you don't want to invest it on the hardware, you can go for cloud. It is very robust. Hadoop is architected with the assumption of frequent hardware malfunctions. When you have more than one machines in your ecosystem, then definitely one or more machines are always failing. So even though the machines are failing, Hadoop is good enough to actually run the process continuously on other machines also, and it can gracefully handle most of such failures. And it is scalable. It is the most important feature of Hadoop. So Hadoop scales linearly to handle larger data by adding more nodes to the cluster. So if you have data continuously increasing, then I can scale it easily by adding more and more nodes to the system, and Hadoop can actually accept any number of machines and then process the data. It is simple because Hadoop allows users to quickly write efficient parallel code, because here we are now not writing programs which are going to execute on single machine but on multiple machines, right? So as a developer, you really don't need to worry about how to distribute it, how to process the data distributedly on different machines, and data locality. So here, when we process the whole data on a single machine, we bring the data to the process, but that is going to take a lot of time to process the data because we have a single processor. But now in Hadoop processing, it is exactly the vice versa of this, meaning that you first prepare the data on or copy the data or distribute the data onto multiple machines, and the process or the program that you want to run, you basically move that to all the machines where the data is located. So we call this as data locality, and this important feature is used by Hadoop across all its technologies. And last but not least is replication. So whenever a machine fails while processing the data is also lost. So in order to make sure that data is not lost, Hadoop copies the data or replicates the data on multiple machines, so that if a machine fails, it can actually go to the other machine where it has a replica and continue processing that particular data. So how did Hadoop come into picture? So Hadoop was actually, as I said, inspired by Google's MapReduce papers, and Duck Cutting, an engineer who was actually working on a web search project, was facing a lot of scalability issues for his project. And then he actually saw the Google MapReduce and GFS papers, and then started using that particular white paper to create a technology so that he could solve his problem of scalability of the web search. And internet was very much used during the 2003 and 2004 time, so he was facing these kind of problems. So then he started building a software which is just not going to solve his own problem, but it can solve any other problem where data is actually increasing on a day by day basis. And then he joined Yahoo later, and then Yahoo and Cutting actually did a lot of research, and then they came up with this Hadoop software. And if you can see at the bottom, the Hadoop name is not an acronym; it's just a man-made name. So the project creator Duck Cutting explains that it was named after his kid's yellow elephant. So his kid was playing with an yellow elephant. He used to call it as Hadoop, and he could easily relate the bigness of an elephant with the bigness of the problem that he was solving, and he um, gave the name Hadoop to his software. And these days, a lot of people use Hadoop, a lot of companies, Yahoo, Facebook, LinkedIn, wherever there is huge amounts of data, people start using it. And there are a lot of use cases currently going on in Hadoop, irrespective of what is the vertical, like the financial services, retail, manufacturing, healthcare, web, social, government, all of these things. These days, everybody is storing huge amounts of data, and definitely there is a need for um, processing that particular data. So Hadoop has its own ecosystem. So each one is actually a component to solve a particular problem. So HDFS, which is a descendant of GFS paper, which is called Hadoop Distributed File System, which is going to store the data distributedly on multiple nodes. The second component is MapReduce, which is the processing engine in Hadoop, which is going to divide this particular data and then process the data accordingly. And there are many other projects that have come up after this Hadoop, HDFS, and MapReduce. MapReduce requires knowledge of Java to write MapReduce programs. So many people might not be very comfortable with the programming language, as many people are database analysts or database programmers. So Facebook actually came up with this component called Hive, which is going to actually run SQL queries on top of flat file data which is stored in HDFS. And Impala is a tool which is going to improve the performance of Hive queries. And Pig is a scripting language to as an alternative for MapReduce programs to query your data. Mahout is a scalable machine learning language. HBase, scalable distributed database. Zookeeper, a high performance coordination service. And then Scoop, if you want to import and export the data from an RDBMS to and from HDFS, you can use this tool. Similarly, Flume and Uzi. So all these and many more components which form the ecosystem of Hadoop are serving the clients, and then everyone is solving their problems accordingly.